Aiden's going to explain to us how he did the bell ringer. Let's pay close attention. Aiden, make sure whenever you say the coordinates, make sure you speak loudly and clearly so those on the video can hear you, because you can't see the board. All right, go ahead.
You don't know me that. So it says here, do a 180 rotation. So you just change the signs on all these. So you get A prime is -2, -4. B prime is 2, 5. And then C prime is 6, -7. And then your roll is -8, -B.
Thank you. Andrew, tell us, do you agree or disagree?
I agree.
Yeah, very good. So whenever it's a 180-degree rotation, all you do is go through and change the signs of all the coordinates. We will have a bell ringer tomorrow, and then depending on how much we get through today depends on what we'll do tomorrow after we go over the bell ringer and turn it in. All right, I need you to get out your 5.4 notes, dilations. Has anyone heard the word dilation before?
We all have.
Dilate your eyes.
Yeah, your eyes, they dilate, your pupils dilate. What does it mean for your pupils to dilate?
Enlarge.
They get really big or they can get really small, depending on how much light there is around you. If there's a lot of light, they get really small. And if it's dark, then they get, kind of big. Okay. That's dilations in geometry. Your figures are either going to get bigger or they're going to get smaller. And they're going to tell us, and they get bigger or smaller by a scale factor. Okay, your scale factor is how much bigger they got or how much smaller they got. And then depending on what your scale factor is, it determines if it's an enlargement or a reduction. And there are some rules to go along with that. I just passed it out. I may have.
Whenever mine does it, I can't see. Is that for everybody? Like if everything's fuzzy, I can't read them.
When you get your eyes dilated, like as eye doctor, yeah, it's supposed to make them so big so you can easily clean your eyes. So like when I do it, I get a little bit headache because everything is coming so bright.
Yeah, and that's why they make you wear those special glasses.
They didn't give you no special
Yeah.
Really?
They
Yeah, because like whenever it's light outside or whenever there's light around, your pupils get smaller, so that way you don't take in as much light to damage your eyes. Because if you take in too much, your eyes will be damaged. So when they dilate your eyes, they make them bigger, and they won't shrink whenever you get in the light, so it'll damage your eyes.
So they're down. Yeah, they've never done that for me. They just give you the different treatment.
Yeah, they're supposed to get smaller when you get in sunlight.
I told them never to do it again.
All right, so it says students will be able to identify and perform dilations. Okay, let's go back. Maybe. All right, so a dilation, as we said, it enlarges or reduces a figure to make a similar figure. The reason they say similar figure is because it's the same shape, it's just not the same size. Previously, with all the other ones, with translations, reflections, rotations, it didn't change size or shape. But now it's going to change the size of it, but it's not going to change the shape of it. And you'll have to make sure and pay attention to which one's your pre-image. So PQR is our pre-image, and P prime, Q prime, R prime is my image. It's the, this would be an enlargement. And this point C, that's your center of dilation, like where they're dilating from. It's kind of like if you think about a flashlight shining on an object, and then it casting a shadow in behind it. Notice this shadow, P prime, Q prime, R prime, is bigger than the original. All right, so a reduction. What exactly is a reduction? How to tell if something's a reduction? Well, first of all, if you have a picture, you can see it's a reduction because it's smaller. But a reduction is a dilation in which the scale factor K, we use the letter K to represent scale factor, is between 0 and 1. So notice you're going to have to fill that in on your notes because it's blank. It's over there on the left. A dilation in which the scale factor K is between 0 and 1. So if your scale factor is between 0 and 1, it's a reduction. And it can be written as a percent, a decimal, or a fraction. So like a reduction would be like 1/3, 2/3, 1/2, 3/4, 7/8. Or you could say 0.1, 0.6, 0.5, 0.9. Or you could say 50%, 60%, 70%. You know, on your page or like on a computer, when you're trying to zoom out, you make it, lower, the percentage lower. That's because you're, shrinking it. And then when you enlarge it, you make it higher than 100%. 100% is the exact same size. All right, and an enlargement is a dilation in which the scale factor K is larger than 1. So if you get a number that's larger than 1, that's an enlargement. It makes it bigger. Okay. So how exactly do you find the scale factor? All right, so in order to find the scale factor, let me write this as a little bit better. You take and the size of the image and you divide it by the size of the pre-image. Okay. So you do the size of the image divided by the size of the pre-image. So you do the new one divided by the old one. Okay, so if prime goes on top and then the original goes on bottom.
Wait, where did you see enlargement?
Yes, it was greater than 1. All right, so you do image divided by pre-image. Okay, so let me show you an example. It says find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. So first you do from C to P prime, and P prime is all the way out here. So from C to P prime is 12, so that one goes on top. And you divide it by C to P. Well, from C to P is 8, so I do 12 divided by 8. Now, when you write that, you can either write it as a fraction, a decimal, or a percentage. If I do 12 divided by 8, if I reduce those both by 4, I'm going to get 3/2, which is 1.5. So you could have either left your answer as 3/2 for the scale factor, or you could write it as 1.5. Or as a percentage, it would be 150%. Okay? Now, since this is bigger than 1, then that means it's an enlargement. So I would put down that it's an enlargement.
Okay. Bigger than 1, it's always enlargement.
If it's bigger than 1, it's always an enlargement. So my scale factor K is 1.5, and it's an enlargement. And you can even look at the picture. See here how the original, the pre-image P, is a small safety pin, and P prime is a bigger safety pin. You can see by the picture that it's an enlargement.
If you see that, you have to work it out? Or can you just...
Yes, because it tells you specifically to find the scale factor. All right, the next one. You're going to have to fill in these numbers first because I whited the numbers out. So you're going to have to fill those in. The long one's 30 and the short one's 18. It says find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. All right, so remember, it's the new over the old. So first you do from C to P prime. Colton, what's the length from C to P prime? Alright, so what you're going to do is find your point C. And here. So find your point C. And then find P prime. And then what's the number that is from C to P prime? 18. Okay, so 18 will go on top.
Right. Okay.
From C to P prime is 18.
So prime's always on top?
Prime's always on top. All right, and then the next one that goes on bottom is from C to P. Ellie, what would be the length from C to P? 30. So 18 over 30. Okay. Now I need to reduce that. 18 over 30. Ivy, what is 18 over 30 reduced to?
3 over 5.
3 over 5. Okay, so my scale factor is 3 over 5. What if I wanted that in a decimal? John, what would that be as a decimal? 0.6. So you can either leave it as 3/5 or 0.6. The only time I would recommend you making picking is if you get a decimal that goes on and on, it's non-terminating. Then I would leave it as a fraction. But any other time you could do it as a decimal. So now you have to say if it's an enlargement or a reduction. Andrew, what would you say?
Reduction.
Yeah, that's a reduction. So 0.6 is smaller than 1. It's between 0 and 1, so that would be a reduction. All right, this one's a little different. In a dilation, from C to P prime is 3, and from C to P is 12. Find the scale factor, then tell whether it is a reduction or an enlargement. Okay, so to find my scale factor, which of those, make sure you fill in the 3 and the 12. Okay. Aiden, which number would I put on top?
3.
3? How did you know?
This is the one you come to first, or the newest one.
Yeah, it's the newest one. It has the prime. And then so that means I put 12 on bottom. All right, Rayleigh, what is 3 over 12 reduced to? 1/4. So my scale factor is 1/4, or you can change it to a decimal. Kyle, what would 1/4 be as a decimal?
0.25.
0.25. So either 1/4 or 0.25, or you could say 25%. Any of those are fine. Caden, would you call that a reduction or an enlargement?
Reduction.
Reduction, perfect. All right, what questions do you have for me? Okay. All right, so the next one's going to be with your partner. So if I can get you to go ahead and turn your desk to face your partner, and then you're going to have to write the numbers down before you can work the problem out.
I think this is definitely the easiest thing we've done.
All right, so here's your numbers you need to fill in. From C to P prime, it's 6, and from C to P, it's 14. From C to P prime is 6, and from C to P is 14. So fill those in first, and then work this out with your partner. All right, if I can have your attention, please. Ben, what did you and your partner get for K for your scale factor?
I got 0.4.
0.4?
Yes.
Is that what everybody else got?
It's actually 0.42. No, 3.
Oh, is it one of those non-terminating decimals that goes on and on forever? Okay. So if you're doing a worksheet, like an assignment, and you put 0.4 or 0.43, I would count that right. However, if you're doing something on big ideas, they will probably count that wrong. So what you would have to do here is leave it as a fraction. So what would that be? 6 over 14?
3 over 7.
3 over 7. So on an assignment, if you wrote 0.4 or 0.43, it's correct. I'm counting it right. But big ideas may count that wrong. So you would want to leave it as a fraction. Okay? And then so my next question, would that be an enlargement or a reduction? John, what did you and your partner say?
Reduction.
Do y'all agree? Does the rest of the class agree?
Yes.
Okay, awesome. All right, here's your next one. Try this one. From C to P is 15, and from C to P prime is 9. Try this one with your partner.
Over 9 reduces to 4.
All right. Alright, if I could have your attention, please. Caden, what did you get as the scale factor, you and your partner?
9/15, and then reduce the, you need to keep going. It goes for 3/5, and then, get 0.6.
Ooh, which one do y'all think it should be? Should it be 9/15 or 15/9?
9/15. No,
Why?
9/15.
Why should it be 9/15?
The new one's on the bottom, which is closer.
Yeah, so C to P prime goes on top, and C to P goes on bottom.
What, I thought prime was always on top.
Yeah, prime is on top. Prime is the new one, which is the smallest.
Okay, and would that be a reduction or an enlargement? Reduction. Alright, what questions do you have for me?
0.
Alright, go ahead and turn your desk back around. Alright, so we have been discussing rules whenever you're doing transformations in the coordinate plane. For instance, when we did translations, it was x plus a, y plus b. A reflection across the x-axis was x comma negative y, because you would multiply the y by -1 or just change the sign of y. And the same thing for rotations. With dilations, the rule xy is translated to k times x, comma k times y. So whenever you perform a dilation in a coordinate plane, all you do is multiply the x and y coordinate by the scale factor, k. So if k is 2, you would do 2 times x and 2 times y. If k is 1/3, you would do 1/3 times x and 1/3 times y to find your new coordinates. So all you're doing is multiplying. So dilations, they'll give you the scale factor, and then you just multiply both coordinates by the scale factor, and then that gives you your new coordinates. All right, so I'll show you an example. It says graph quadrilateral KLMN with vertices K -3, 6, L 0, 6, and M 3, 3, and N -3, -3, and its image after a dilation with a scale factor of 1/3. Okay, so first I'm going to graph the original. So I'll start at the origin. K is left 3 down 6. No, left 3 up 6. Oh, is this not the teacher model? Did it skip one?
Oh, I already grabbed it.
Yeah.
Steady column.
There's one above this. It's A, B, and C, not
Yeah.
A, E, and.
Yeah, this thing's very sensitive. It always
It's okay. That's good.
makes me.
Don't touch my desk. You said D.
You just said D.
No, I didn't.
Yes, you did.
You said D. No, don't be.
Okay, here we go. Alright, graph triangle ABC with vertices A21, B41, and C4 -1, and its image after a dilation with a scale factor of 2. And all of our dilations are centered at the origin, so it's like a flashlight is sitting at the origin, shining on the object. Alright, so A is 2, 1, B is 4, 1, and C is 4, -1. Alright, so now to find my new coordinates, it says it has a scale factor of 2. So what we're going to go through here and do is multiply each of these coordinates by 2. So A prime, 2 times 2 is 4, and 1 times 2 is 2. So A prime would be 4, 2. B prime, 4 times 2 is 8, and 1 times 2 is 2.
So you're just timesing every single one of those by 2.
Yes.
Got it.
C prime, 4 times 2 is 8, and 2 times -1 is -2. And then you plot these new coordinates. So A is 4, 2, or I'm sorry, A prime is 4, 2, B prime is 8, 2, and C prime is 8, negative 2. And then make sure that you're connecting your coordinates. I've noticed some people, like, they plot the new points and then they don't connect those. Make sure you're connecting your points and drawing your triangle. And there's your dilation. All right, what questions do you have for me? All right, let's try one together. You notice you're going to have to fill in the scale factor here of 1/3. So make sure you put that 1/3 in the blank so that way you know what you multiply by. Graph quadrilateral KLMN with vertices K, negative 3, 6, L, 0, 6, M, 3, 3, and N, negative 3, negative 3. And its image.
Oh my God.
And its image after a dilation with a scale factor of 1/3. Okay, so first you do negative 3, 6, so to the left 3, up 6. Then you do 0, 6, so 0, up 6. Then you do to the right 3, up 3. And then you do to the left 3, down 3.
Just because you didn't turn in your Apple One.
No, I did not.
I did if I were you. Daddy. I'll never get on my phone.
All right, there's KLMN. Now you need to figure out your new coordinates. So your scale factor is 1/3. So you need to multiply each of these coordinates by 1/3. So multiply each one of these by 1/3. Yes, it's the same thing as dividing by 3. So K prime, what's negative 3 times 1/3, Gabby? And what about 6 times 1/3, Kyle?
2.
Perfect. So negative 1 comma 2 is K prime. What about L prime? What would be my coordinates for L prime, Ivy?
0, 2.
Perfect. What about M prime, Ellie?
1, 1.
Awesome, 1, 1. And then what about N prime, Ben? Perfect.
Good job, Ben.
All right, so now we graph those. K is negative 1, 2, so to the left 1, up 2 is K prime. M prime is 0, 2, so just up 2. M prime is 1, 1. And N prime is negative 1, negative 1. All right, what questions do you have for me? All right, let's try the next one. Graph triangle PQR and its image after a dilation with scale factor K. You're going to need to write down the coordinates as well as the scale factor. P is negative 2, negative 1. Q is negative 1, 0. R is 0, negative 1. And K, your scale factor is 4. So after you get those coordinates written down, then you graph your original coordinates. P is negative 2, negative 1. Q is negative 1, 0. And R is 0, negative 1. All right. Colton, what am I going to multiply all of my coordinates by to find my new coordinates? 4. So I'm going to go through and multiply everything by 4. John, what would be my coordinates for P prime if I multiplied P by negative 4 or by positive 4?
Negative 8, negative 4.
Awesome. Rayleigh, what about Q prime? What would I get for Q prime?
-4, 0.
Awesome. And Andrew, what about R prime?
0 to 4.
Awesome. Alright, so let's graph -8, -4. Q prime is -4, 0. And R prime is 0, -4.
How many copies is the worksheet?
Perhaps.
You talking about the assignment that you did? 3.
Oh.
Alright, so the next one you're going to try with your partner. You can go ahead and turn your desk around, and then you're going to need to write down the coordinates and the scale factor. Alright, it says, graph triangle PQR and its image after a dilation with a scale factor K. P is 5, -5. Q is 0, -5. R is 5, 5. And the scale factor is -0.4. Let's see what that negative does to it. Alright, so for your new coordinates, you should have multiplied them each by -0.4. So for P prime, you should have gotten -2, 2. Q prime is 0, 2, and R prime is -2, -2. And if you graph that, you can see, was that an enlargement or a reduction?
That was a reduction.
And what did this negative sign do to it?
It flipped it.
Yeah, it flipped it. It was either like a rotation or a reflection, just like what we did previously in with our rotations and reflections. Okay, so that's all the negative sign does to it. That's multiplying both the x and the y by -1, which is the 180-degree rotation. So what this did was it shrunk it. It was a reduction, and it did a 180-degree rotation. Okay, so it's like it combined both of the things together. All right, try the next one.
Okay, the movie stuff that we started. You remember that thing?
All right, you're going to have to fill in the coordinates and the scale factor. For x is 2, -1, y is -2, -2, and z is 1, 2, and k is 3. So fill those in first, and then work that one out with your partner.
You lost a lot of
All right, if I could have your attention, please. For x prime, you should have gotten 6, -3. For y prime, you should have gotten -6, -6. And for z prime, you should have gotten 3, 6. Okay. What questions do you have for me?
What's the page number?
Page 25. In your table of contents, you need to title it 5.4 or 5.4 dilations. And then I would keep them out to help you with the assignment, because after you get your table of contents filled out, you need to get out your student journal.
Okay, 25.
Page 25, or in your student journal?
Yeah.
In your student journal, page 120.
Yeah, my good job. Yeah. Can I rip it out? Yeah.
Yes. All right. After you get page 25 written down, turn to page 120, because there's some stuff I need to change.
You said page 20?
Page 120 in your student journal. All right. In your student journal, you're only going to do numbers 1, 2, and 3 on page 120, but these are all composition transformations, which means there's 2 of them rather than just one transformation. So what you need to do on numbers 1, 2, and 3 is don't do the other one, only do the dilation. So like on number 1, don't do the translation, mark that part out. On number 2, don't do the reflection. And on number 3, don't do the rotation, only do the dilation. Now, also, number 1, I need you to change those coordinates. Because if you don't change the coordinates, you're not going to be able to fit it on the graph. So for A, I need you to do the original coordinates, -2, 3. For B, I need you to do -3, 2. For C, I need you to do -1, 0. And for D, I need you to do 0, 2. 0, 2. Okay? And I'll zoom that in a little bit so you can see it better. So don't do these coordinates here as A, B, C, D. Do these coordinates as A, B, C, D. And that's because if you do the other ones, you're not going to be able to fit it on the graph. Okay? And only do the dilations. Do not do the translations, reflections, or rotations. Only do the dilations. Okay? All right, so you're going to have the rest of class. Do I need to pull those numbers down again?
Yeah, I pulled up on paper.
Okay. You're going to have the rest of class, which is a little, about 7 minutes to work with your partner.
Exactly.
If you don't finish, it'll be homework due at the beginning of class tomorrow. And then Kaladin, whenever you're finished, you can just take a picture and send it to me.
How are we supposed to get negatives on the graph?
They're over there. Only the X values are negative.
I don't get the
Oh,
dilation. Like, if it's 1/4, you times all of them by 1/4?
Yes.
Okay.
Yeah, and 3X means do 3 times X. 3Y means 3 times Y.
Oh, boy.